It is a touch screen, yeah. Is it running? Okay, thank you. All right. Arise. Here. All right. Use your cheat sheets if you need to, otherwise, let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Sanctum Michael Arcangelo, defende nos in premio, contra nequitiam et insidias diaboli, est presidio. Impere Filii Deus, supplices te pregam, tuque princeps malitia celestis, Satana, aliosque spiritus malignos, qui ad perditionem animarum pervegantur in mundo, divina virtute in infernum deturum. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. Let me see. I'm thinking we need to space things out just a teeny bit more. Andy, if you'd be so kind, I'm going to move your seats up to here.
Are you kidding me? Oh my god, are you serious?
We sit next to each other in every class.
And me and Eric sit next to each other in every class
single
too.
class.
Yeah, thank you.
True.
Yeah, they plan.
Okay, I can do one other thing if you absolutely must. But, Josh, if you'd be so kind.
This is the only class I'm in the back.
Well, life's rough. Tell you what, let's do it mathematically. You two gentlemen, I was thinking a number between 1 and 10. What is it?
You better get it wrong.
Hey, Josh.
That was it. Okay, Josh, sorry.
No, Mr. Osman, I need to at least have a guess, because that's unfair.
Well, I guess three.
That's the exact number.
Oh.
Can you do like a different one with me? No, he's the one in the number. If I don't get the number.
No.
Up and at 'em, my
I haven't
friend.
guessed yet, so stop taking
Up and at 'em, my friend. Okay, and then Andy, off to the other end. So off to the end. Thank you. Yes. That is yours. And Rosie, I'll leave it up to you if you want to sit in the middle or at the end. I'll leave it up to you. They're both free now.
Wait, is
he's
that
ready
a
for
permanent?
the section.
Is that a permanent move?
Correct. Correct. All right. Take out, please, your in class 62, the worksheets. The whole thing is not due today, but 1 through 20 is. So I'm going to be coming around to check that momentarily. For the people listening at home, you might want to fast forward about 2 minutes. Let me see what you have.
Which is like
No, this is okay. We need to get the princess out.
Hey, Rosie.
The rest is due tomorrow, that is correct. Yeah. And then the rest of it's due tomorrow. The only way they work is if you get 2 identical parentheses.
No, I mean, so like, in this problem, could I move the 9 and 5 over there because they move each other?
Oh, yes, but you don't have to. It'll work either way. It should work either way.
I was taking the test on whatever, and so I didn't get all the notes, so I just took them.
Okay, that's on the video. So jump online tonight. I sent a link to everybody home. On the YouTube channel, there's a video, 8th grade math. Look for factoring by GCF. It'll cover the notes. If you can get the entire thing by tomorrow, I'll be fine.
Like, do you have another sheet?
Whatever you're old. You need to hang on to these. I'll be right back. I need to check out first.
Josh, which one do you choose?
Oh,
That's what John No, it's fine, I'll tell you.
Okay. Grab a red writing utensil. Have it at the ready. The answers are as follows. Number 1. 2x squared plus 6x plus 4. Have we guessed that? 2x squared plus 6x plus 4. Number 2. Negative 5x squared plus 35x plus negative 30. Yeah.
What was the first number?
Negative 5x squared. Yeah. Number 2. Yeah. Negative 5x squared plus 35x plus negative 30. Does anybody else not have it in class 62 that they need? Speak now or forever hold your peace. All right. John, I'll have to print off an extra copy for you.
Okay, thank you.
Number 3. X to the 4th plus negative 4x squared. So if you have x to the 4th minus 4x squared, that's fine. Number 4. Negative, listen carefully on these, there are two different powers on the x and on the y. Negative 2 x to the 3rd y plus negative 2 x y to the 3rd plus negative 2 x squared y squared. And we need that repeated. And it repeats up to number 4. Alright, number 5. 4 terms. Negative 1x cubed, or just negative x cubed, plus x squared, or 1x squared, plus negative 1x, plus 9. Yeah.
Can you repeat that?
Yeah. Negative 1x cubed, plus 1x squared, plus negative 1x, plus 9. If you just said regular x squared or regular negative x, that's fine. Number 6. 2x squared plus 3x plus 5. If you left them as fractions, make sure you reduce them. If they're reduced to whole numbers, that's even better. Number 7. 8 parentheses x plus 5. 8 followed by parentheses x plus 5. Number 8. X parentheses x plus 8. Yeah.
I have a question. So for the test, will there be like 3 problems where we will like solve this by GCF, and then will there be like another 3 problems which is gonna be like solve this by grouping?
Yes, and the short answer to that is there will be some questions where I say factor by GCF, factor by unfoil, that we're going to cover that today. Factor by grouping, blah, 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 blah. And then I'm going to give you like 5 or 6 of them saying factor any old way that works. And then you get to choose. Yeah. Then you'll have to know which ones work. Number 9, 25x squared, parentheses, x plus 4. And it repeats up to number 9 so far. Right. Number 10, negative 8, parentheses, x plus negative 5. Yeah. Okay. Number 9, 25x squared, parentheses, x plus 4. Yeah.
Can you say 10 again?
10, yeah. Negative 8, parentheses, x plus negative 5. If you had negative 8, parentheses, x minus 5, that's okay. Number 11, negative 4, parentheses, x plus negative 6. Remember, if the first term is negative, you have to pull out a negative GCF. Okay. Which one was that again? 11, okay. Negative 4, parentheses, x plus negative 6. Right there, number 11. Number 12, negative 1x, then parentheses, x squared plus negative 3x plus negative 2. All in parentheses. Number 13, it's prime. Number 14, yeah.
Is it fine if you just wrote 7x plus 13?
Oh, if you wrote it again? Yeah, I'll accept that. Yeah, if you just recopied the original problem, that's fine. Did anybody do 1 parentheses 7x plus 15? I'll let that go, although I'll look at you funny because reasons. Yeah. 12 was negative 1x, and then parentheses x squared plus negative 3x plus negative 2. Anybody else? Up to number 13. Number 14. The GCF in front is a b squared c. So in front should be a b squared c. Question? Yeah, that's very nice. And then inside is parentheses a plus c plus negative 1 a squared b c squared. Let me say it again. The outside is a b squared c. Let me just write this down. It's a little easier to tell. So you've got a b squared c followed by parentheses a plus c plus negative 1 a squared b c squared. Makes sense?
You don't need the one, right?
You don't necessarily need the 1, correct. And you don't need 1s in here either, but they're fine. Yeah. Number 14, good. Number 15, 2 parentheses, x plus 1 and 2x plus 5 squeezed next to each other. Number 16, it does not factor by grouping. It is 5 parentheses, x cubed plus 4x squared plus negative 3x plus 20. Can you repeat so far? Number 17, x to the 18th, then parentheses x squared plus 5. Number 18 is kind of big. The GCF is negative 24 x z cubed. So negative 24 x z cubed. Then inside should be y to the 5th, z to the 7th, plus negative 4x. Any repeats on that? Yeah.
Maybe 60.
16, yeah. 5, then parentheses, big parentheses. X cubed plus 4x squared plus negative 3x plus 20. Number 19, the GCF in front is x to the 30th, 30, followed by parentheses x to the 70 plus 8x to the 20 plus 24.
Can you say that again?
Yeah, x to the 30th, parentheses x to the 70th plus 8x to the 20th plus 24. Okay. That was number 19, right? Number 20, there are 3 things that pull in front. Negative 4, x, and parentheses x plus 1. All 3 of them pull in front. Then the leftovers are parentheses 2x squared plus negative 1x plus negative 4. Let me read that again. Negative 4x in front, then parentheses x plus 1, then parentheses 2x squared plus negative 1x plus negative 4. Yeah. So it's done. It's fine. Okay. Any repeats on the whole thing? Alrighty, let's follow this up. Ooh, where is it? There it is. Alright, questions? Any of those you want to see dissected? Don't be bashful on this one. Because the factoring is one of those things where it goes step by step. Once you leave one topic behind, it'll assume you know how to do it. And then you may have to use that as a basis for another one. So if you're at all foggy about this, don't sit there and suffer. Call out an answer. Yeah, question.
Unless you say like specifically like factor by grouping or something, do you always look at factor by GCF and then you factor by grouping if you can?
Right. As a matter of fact, as we go on, there are 7 different methods of factoring. I'm giving them to you more or less in the order you should try them. Always, bless you. I'm going to emphasize this today in today's notes, but you always check for GCF first. There are some interesting problems that factor like 5 times in a row. Like you could factor the GCF out, then it factors by grouping, then it factors by some other method, then it factors by some other method, and then you're done. But you always check GCF first. Yes. Question?
I mean, like, no offense or anything, what's the point of
Oh, that's a
factoring?
great. What's the point of factoring?
Yeah, I mean.
Factoring is arguably the most important algebra skill you're going to learn. It shows up literally everywhere. Every single math course above this is going to assume you know how to factor, and it's going to show up everywhere. If you don't know how to factor, you are mathematically crippled when you get into second year algebra, pre-calc, or calculus. You would not be able to do them without it. So yes, it's very, very important. So for now, take it on faith. A little later on, I'll show you why that's true. Well, I can show you a quick example now. Somebody do it for me. Where do you start? We just did a section on this. Yeah.
You see if 2 can go into 1 and it can't, so you flip to 0.
Right.
Okay.
Answer 0. Now what?
Then you look at the first term and the first term.
First and the first. I'll turbo this. How many times? I don't know. Let's find out. How many times does it work? What do you get?
X.
X. It goes in X times. Keep going.
And you do X times X, which is X squared.
Okay.
And you do X times 5, which is 5X.
5X. And then what?
Then you add the opposite.
Add the opposite. These cancel. This becomes 2X. Now what?
Then you bring down the 10.
Okay.
Then you look at X and 2X.
Okay. How many times? Go ahead and cut to the chase. 2
2.
plus 2, and then multiply. You should get 2x plus 10. Glory be to God. There's no remainder. Done. I'm going to show you this method today. I'm just going to give you a little teaser. The technique we're going to learn today is called unfoil. This is one of the reasons why I had you learn FOIL. Can you think of 2 numbers that add up to 7 and also multiply to be 10? There's only one pair of numbers that ever does that. Let me know if it's up there. 2 numbers, they add up to 7, but they multiply to be 10. Who do you think? Go. 2 and 5. Put a 2 here, put a 5 here. Can somebody tell me what x squared splits into? There's only one thing it split into. What times what? X times. You just factored, by the way. That's the method we're going to do today. And may I point out, that's exactly what you got here. If you know how to factor, it can sometimes replace long division. You don't have to do long division if it factors. That's one of many, many, many uses. That's just one. Okay. Next questions. Any of those you want to see worked? Again, I'll do unfoil later. But any of the ones on the worksheets that you didn't know how to do or did not have the right answer and would like to know. You're just sitting there and yes, please. 14. A squared B squared C plus A B squared C squared minus a cubed b cubed c cubed. Okay. Tell you what. Isabella, how many a's do all these terms have in common? One. Why do you say that?
We each have only one A.
Right. Which term was limited us to one? The first, second, or third
The
term?
second
Second
one.
term. This could give away two A's, this could give away three, but this is only one. So they all only have one A in common. Make sense? Andy, how many B's do they all have in common?
Two.
Two, correct. What would you write?
B squared.
B squared. Rosie, how many C's do they have in common? One. Because of this one. Can somebody tell me the leftovers? When you divide all those out, when you rip all those letters out, actually, Kevin, what's left? How many A's are left here? One, exactly. There were two A's in the first place, and I ripped one out. How many B's are left? None. How many C's are left? None, exactly. We're done with the first term. Plus, John, take over. How many A's are left? It started with one A, and I ripped one A out.
None.
None. How many B's are left? Started with two B's, and I ripped two B's out.
None.
None. Started with two C's, and I ripped one C out.
One.
Yeah, there's a single C left. Minus, Eric, take over. How many A's left?
Negative
Two. So A
squared.
squared. How many B's left?
One.
One. How many C's left?
Two.
You're done. Does that make sense? Does that answer that? Any other ones you want to see? Now is the good time to ask. If there are any of those that you did not get right, you should be raising your hand and asking. This is the good time to ask. No question is too humble. I wanted to say, I know, if you're wondering, I'm like, I don't want to ask about that one, it's too dumb. I do not put dumb questions on my worksheets. Unless it's a typo, in which case, yeah, that's really stupid. Yeah. 20. Yes. Negative 8x cubed. Oh, man, I'm just gonna clear this with, give myself a whiplash. Negative 8x cubed parentheses x plus 1 plus 4x squared parentheses x plus 1 plus 16x parentheses x plus 1. Now remember, when you're pulling out a GCF, a common factor, sometimes they're numbers, sometimes they're variables, and sometimes they're parentheses. So Rob, help me out here. Is there a number that all, just start with a number. Is there a number that all three of those have in common?
X plus one.
That's not a number though. Do the numbers first. You can do a little better than one. Look at the numbers in front of you.
4.
4. That's better. Now, all of these, does everybody see why there's a 4 they all have in common? 4 goes into this, 4 goes into this, 4 goes into this. And there's one tiny catch. What kind of 4? Go. Why negative? Right. If the first term is negative, pull out a negative GCF. So negative 4. That's a little bit of your GCF. Mary, take over. How many x's do they have in common? Do they have like x or x squared or x cubed? X. Just plain old x. This has 3 x's to give. This has 2. This only has 1. So all of them can give up 1 x in common. Is there anything else all of these have in common? Brendan?
There's the plus 1.
Sort of. A little more than that. The whole.
Well, the x plus 1.
The whole parentheses x plus 1. They all have the parentheses x plus 1 in common. Yank that in front. Now I'm going to make some great big parentheses for the leftovers. Mia, help me out here. What's left after you get done dividing all of this out? The negative is gone, divided by 4, 1x is gone, and the parentheses is Good, and the parentheses is gone. First term is done. So we see how we got that. Everybody following? Negative 8 divided by negative 4 is 2. One of the x's is ripped out, leaving 2 behind, and the parentheses is ripped out, leaving nothing there. Okay, Jack Edward, help me out with the next term. Now be careful, you're dividing by negative 4. So what's 4x squared divided by negative 4x? Yeah, negative x or negative 1x. Either way. Anything else or no? Correct. Nothing left. The 4 is gone, one of the x's is gone, and the parentheses is gone. Alright, Therese, help me out with this one. 16x divided by negative 4x. Yeah, and is any parentheses left or no? You're done. That's the end of the problem. Does that make sense? Any others you want to see? Good question. Yeah. Number 9? Yeah. Yes. 25x cubed plus something I forgot. 100x squared. Out it is done. That's done. Help me out with this then. What's the biggest number these both have in common for dividing? Yeah, 25 definitely. How many x's do they have in common? 2. So what would you write? X squared, good. If you divide that out, what does this first term become? What's that? We'll do one piece at a time. What's 25 divided by 25? 1. And then x cubed over x squared? X, correct. Plus, let's try this one. What's 100 divided by 25? 4. And then how many x's are left? 0. So you can just leave it blank. And that's right. Does that make sense? Are we feeling a little better on this? Any other ones? Now's a good time to ask. Sure. So everybody, I could throw any of these on the test? Yes.
Can we ask about problems on the next page?
After the notes, yes. Questions? I'm just going to do one extra example of factor by grouping. So everybody else is good to go? Take out your notes, please. Example.
So for factoring, since you can switch around the order of addition, if you just switched around the order of the way they were being added.
Like the
would you
two
get-
middle terms?
Yeah, like would you get different answers?
I'll show you an example of that. The short answer is yes, you can do it, and you'll get the exact same answer. So it's pretty foolproof. Let's try this. 2x to the 4th plus 10x cubed plus 6x squared plus 30x. I would like you to factor this. Should I write this back? So again, 2x to the 4th plus 10x to the 3rd plus 6x squared plus 30x. And I would like you to factor that. There are two methods of factoring that we know. GCF and factor by grouping. Which one do you always check first? Always, always, always. Go. GCF. You always check any factoring problem with GCF first. If there is a GCF, you can pull it out and the rest of the problem becomes easier. If you leave it in, not only will the answer be partially wrong, but it'll also be a lot harder to do. Any suggestions what to do first? Ken?
Would it be 2x?
Yes, there is a GCF of 2x. So let's pull the 2x out in front. What would you be left with if you did that? Trust question or answer?
I have a question.
Okay.
If you get two, like, that you can add, are you supposed to simplify it?
Oh, if you find two that are like terms?
Yeah.
In the factor by grouping section, no, you actually don't. Very good question. Under ordinary circumstances, yeah, we like to add like terms. But how many terms do we need to make factor by grouping work? Remember? 4. You need 4 terms. So if you combine the terms, you'll only have 3, and it'll short circuit factor by grouping. A very good question. And there's, I'll be able to answer that in full next week when we have method number 6, called magic pair, which sounds mysterious. We'll call it that. From 2x, can somebody tell me what's left over? Yeah, go ahead. Was okay. Good. Plus 15. Let me see where that came from. You're basically dividing everything by 2 and ripping 1x out of everything. So you're dividing by 2x. Question.
If you had a grade term polynomial,
Okay.
and the last one didn't have an x, it was just like say it was like 30.
Okay.
And you wanted to factor by grouping, could you like break 30 into 2 things and then factor by that? Or if it had like 5, break that.
Is it, the question is, if you had a 3-term polynomial, is it possible to break one of the terms apart so that makes you get 4?
Yeah.
The short answer to that one is yes. That again is part of the magic pair trick. That's gonna be next week. Magic pair trick. I'm not talking about the stuff you eat. I'm talking about PAIR, not PEAR. It's like it's a long story. I'll tell you that next week. Once you learn unfoil, magic pair will make sense. If you do not learn unfoil, magic pair will be completely confusing. So do get comfortable with unfoil, which I'm going to be covering a little bit today and mostly tomorrow. Okay, that's not for tonight's session. That's for next Sunday. Now this thing, the 2x is nice, but does anybody notice the stuff inside? How many terms? Here. 4. What method might work?
I don't know.
There's a method that works with 4 terms. Yeah, factor by grouping. No guarantee it'll work. There are some factor by grouping things that don't. But let's just try it. The way factor by grouping works is you group the first and the last pair. Don't capture the middle plus sign, by the way. Don't need it. And then look for little mini GCFs. Again, it might or might not work. And it looks weird just factoring out a piece of something. You're normally not supposed to do that. But just for fun. By the way, leave this 2x out in front here. I'm going to make these big honking parentheses here so you don't confuse them. Here, this little miniature parentheses. Is there a little mini GCF that goes in there? Mary, help me out here. Is there a mini GCF for x cubed and 5x squared? X squared. What would be left behind if you did that?
X and 5.
Yeah, x plus 5. Good. Let me see. Isabella, what about 3x plus 15? Is there a little mini GCF for that? Over here's the middle plus sign. 3. If you divide that out, what's left?
X plus 5.
Exactly. Anybody notice anything suspicious? Look what we have so far. Two parentheses match. Yes. What does that mean? What can you do now? Is this going to work? Is factor by grouping going to work there? Yes, no? Factor by grouping works when the 2 parentheses are equal. So in other words, yes. What do you do with it? What do you do with the parentheses that are identical? For example, these both had an x squared, I pulled it in front. These both had a 3, I pulled it in front. These both have an x plus 5. Guess what I'm going to do?
Don't you like add them or something?
Kind of. You pull them in front. You undistribute them. Leave the 2x from the first part, then parentheses, what's coming out in front? Here. What do these both have in common? Right, pull that in front. Just as is, just copy and paste. Don't do anything fancy or don't raise squared or anything like that. Just yank. Can somebody give me the leftover parentheses? Go. What's left over? I yanked the x plus 5 parentheses out. What's the only thing that's left?
X squared
Yep.
and 3
And then something
plus 3.
plus 3. You are looking at your balance. Okay. Anything that two terms have in common, multiply in, you can yank in front. Okay.
Oh, no, I know.
Oh, sorry. Do you see here? They both had x squared in common, so you divided it in front. You undistributed. Yeah.
Could you start with the factor by grouping?
Could you start with a, yeah, short answer, yes, kinda. But there's a high risk of getting the answer partially wrong. The question is, could you do factor by grouping first? Yes, tell you what, I'm gonna turbo speed this and I'll show you why. So 2x to the 4th plus 10x cubed plus 6x squared plus 30x. Whoops, no 30x squared, it's 30x. All right. Now, I'll leave it up to you. I'm about to do this turbo speed. Hang on. And some blood in my hand here. All right, ready? Go. Okay, group. Okay, common factor is 2x to the 3rd. Behind is x plus 5. This is going to be a 6 in common and an x. There's going to be an x plus 5 in common. Then the x plus 5, oh look, there's a common factor. You pull it out in front. You have x plus 5 in front. Left over 2x cubed plus 6x, ta-da. Okay, thanks. Now, there's a little bit of a problem. This has a GCF buried in it. Guess what the GCF is? Yeah. 2 and also an x, which is what should have been pulled out in the first place. Now, a lot of people get confused here. They think, should I just distribute it into here? No. You actually sort of leapfrog it. 2x gets pulled out in front, x plus 5, and then left behind should be x squared plus 3. That would be the right answer. If you left it like this, I would take off at least 4 points out of 10. Okay, so be careful. If you miss a GCF and leave it in there permanently, that's a problem. It's not fully factored.
Wait.
So this is the unfoiling.
This is not unfoiling. This is just reviewing factor by grouping. Yeah. So factor by grouping, I just say if there's a GCF, always check for that first. GCF has the highest priority. Pull out the GCF if it exists at all. Then leave it in front and you don't even have to trip over it. Then the rest of it's smaller and easier. Question?
So you can still do it the way you did it, but you can do it like at the end, right? You can.
Right. It's a little higher risk because people can forget to do it at this point. They have this sense of satisfaction of, 2 parentheses, I'm done. No, you're not. And it's a little harder to say, do I pull it into here? What do I do with the x plus 5? And it gets a little confusing and people can trip over it. Usually it's easier to pull it out first. GCF first. Rosie, question?
So should we do that on our homework?
On the homework, do the GCF first? Yes. I would say hammer it into your head, GCF first, GCF first, GCF. I mean, if there's no GCF, then it's not your fault. But if there is a GCF, pull it out first. Is it technically possible to do it second? Yes, but it's risky. Do it at your own risk. And I wouldn't do it, frankly. Trust. Okay, Rob.
So on the homework for tonight, if there is a GCF, do you want us to do that?
Definitely. Yeah. The GCF has to come out eventually. I mean, if you already did it by grouping and you forgot to pull out the GCF, you don't have to redo it all, but definitely pull it out. Like if somebody did this and got the end correct, I'd give you full credit. I'd be hanging on my chair seat really. Oh. Okay, so like don't scare me like this. Normally people said, all right. But here, be careful. A lot of people will leave it like this and lose points. I would rather you not be one of them. Okay? Any questions on factor by grouping? I promise to give you one example of factor by grouping where you switch the terms and see what happens. Let's try it. Here. Please do write this down. This is an example I'd like you to know. It's brief. What happens if you do the middle terms in a different order? X cubed plus 6x squared plus 5x plus 30. And I want to see what happens if you get the two middle numbers switched up. X cubed plus 5x plus 6x squared plus 30. Now it's not in standard form that way. It's out of order. But just out of curiosity, let's see what's. I think there are a couple where these two terms are like terms, and you're wondering if you can swap them back and forth. Let's see what happens. I'm gonna semi-turbo this. I'm not gonna go quite as fast as before. There's a GCF of x squared here with an x plus 6 left over. Does that make sense? Did we see that? Yeah.
We have to write this.
Yes, this one I do. So we're going to compare these two methods. Plus, there's a 5 here with an x plus 6. Question, is this going to work? Is factor by grouping going to work in this case? Yes, tell me why. Parentheses are the same. What do you do with the parentheses now, if they're the same? You pull them out front. Go ahead and do it. What's in front? X plus 6. Give me parentheses with the leftovers. Exactly. X squared plus 5. Here's your final answer. Make sense? What if we get the order wrong? What would happen? Josh, help me out here. What's the little mini GCF of this pair? What's the biggest thing that goes in four? What do they have in common? An X. There's no number they have in common, just an X. If you yank the X out, what's left? How about here? Pull one of the X's out, what do you have left? X. I know what you meant. X.
Okay.
That's X cubed. Take one X away and it's now X. This is X to the third power.
X squared.
Exactly, X squared. And then plus what? Yank an X.
Just 5.
Exactly. Take over Jack Gilbert. What's the GCF for this pair? Take it. 6. What's left behind if you divide the 6 out? Exactly. Notice anything? John? Is this gonna work?
What?
Does it look like it's gonna be good or bad? Over here, we had well, it's not just a matter of opinion. It's not just are they made up nicely, but are the parentheses the same?
Yeah.
Yes, that's called the common factor. I'm gonna pull it out in front. So the x squared plus 5 yanks out in front. Can somebody give me the leftovers? Okay. What's the leftovers after you pull the parentheses out in front?
X plus 6.
What's your final answer? Notice anything from grade 2? Yeah. They're the same, just switch the order. Is that legal to switch the order like that? Yeah, what's the property called? Remember? Yeah. Starts with a C. Go. Commutative property. 2 times 3 is the same as 3 times 2. When you're multiplying things together, you can swap parentheses back and forth. It's perfectly legal. In other words, if you swap the 2 middle terms, all you're going to do is swap the parentheses. You get the exact same answer. Make sense? All right. You got a little over 5 minutes. You're welcome to use that for the rest of the hour. Polish off 21 through 30. Try the extra credits. Never hurt anybody much. Try that out. Those of you listening at home, this is my hand waving goodbye. See you later.